Alright, so we're going to start with number 8 here. Notice the magnitude of the acceleration experienced by an electron in an electric field of 600, for me, 600 newtons per coulomb. In your Y, so this is number 8. It's number 8. In your Y, one of the things you need to show is that you understand what an electric field is. So I might start off with something like an electric field is an area where a charge feels a force. And then since the electron is charged, it has a force. And probably the second understanding to make sure you show is that E fields point in the direction a positive charge feels a force. And if you wanted to make sure that you covered all your bases, I had also mentioned that electrons have negative charge. And one quanta of charge. So you've shown that you understand what an E field is. An electric field is the direction by default an electric field points. The fact that since an electron is charged, it will feel a force, and how the physical qualities of that charge on the electron. So that would be a complete plot. Actually, this one mentions force, doesn't it? So we need a force diagram. So I'm just going to do it down here. Well, which way? Sorry. I'm just going to pick this direction to be for my electric field. And I'm just going to label that E. My electron we'll put right here. And I'll put a negative on that. And that's going to experience a force in that direction. And let me just check something. And it's also, therefore, going to accelerate this way, right? So that would be my force diagram, and I need to show the direction of that acceleration. So that actually, in my Y, I've already come across and answered that it's going to be opposite the field in the second part of this. So, equation-wise, I'm going to look at my equation sheet and pick out the fact that I have two equations about electric field. Remember, the left-hand one describes the field because of what's creating it. The right-hand one describes the field because of the charge, what it experiences in the field. So that's actually the one I'm going to use, the E equals F over Q. So E equals F over Q. I might also look back and grab that the sum of the forces is ma, grab Newton's second law there. I think I'll stick with variables here until I until later. That's okay with everyone. So I'm going to rearrange this one so I have EQ equals F, and that's the only force acting on it. So I can replace that F with MA, and I know that they're in the same direction, so I'm going to drop my vector symbol. The directionality is going to be the same. Now I know enough. I can grab things from my equation sheet, and especially the one where I need to go on it is on the back of my rubric, which has the constants on it, because I need a couple of things from here, like the fact that the mass of an electron is 9.11 times 10 to the minus 31st kilograms, and that the charge, one quanta of charge, the amount of charge an electron has on it is 1.602 times 10 to the minus 19th coulombs. So I need those two factors back when I'm over here, and now it's substituting in. My electric field was told me to be, for me, 600 newtons per coulomb. Charge of my electron is 1.602 times 10 to the minus 19th coulombs. Now notice I'm just putting in the magnitude of it. I've already resolved the fact that it's negative in my force diagram and in knowing that it points opposite the field. And then the mass of my electron being 9.11 times 10 to the negative 31st kilograms. And the only thing I don't know is my acceleration, the magnitude of my acceleration, and I can solve mathematically for that. I know I kind of talked quick, but any questions on that one? All right. So number 4, your T-shirt out of the washing machine. Notice it has this many extra particles on it. And as we were just talking about, I guess you could notice that by a couple of different, well, maybe it's by the mass. And each one's either an electron or a proton, and it's given this net charge. And then you're asked how many electrons are attached, and what is the mass of particles attached to your T-shirt. It's kind of funny that the mass is the second question, because that would be, in my mind, the only way to tell how many you have attached to it. You know, unless you have some macroscopic vision, I think. So, in your Y here for number 4, you would want to focus on that an electron carries 1 quanta of negative charge. Oops, that's a negative. Of negative charge. And that 1 proton carries 1 quanta of positive charge. I might even go as far as, since the shirt has a negative net charge, there must be more electrons than protons. I mean, the last one you could put in there is, you know, that the protons and electrons have different amounts of mass. I don't think you really need it. All right. Here, starting in on our how, I'm going to use E for the number of electrons. Actually, I'm going to use N sub E for the number of electrons and N sub P for the number of protons. If I add those two together, in my problem, I get That's that 1485. All right. Um, from my equation sheet, I know that a couple of things. One, I know that one quanta of charge is 1.602 times 10 to the minus 19th coulombs. And if I'm looking at the total charge on something, that's Q times the number of quantas. So it's that Q equals NE. So that's really my only physics equation here, is that Q equals NE, and then the value of E. For me, Q equals, just to get it all on the same page here, negative 402 times 10 to the minus 17. Negative 4. .02 times 10 to the minus 17th coulombs. So that's due just to the extra electrons. So I can figure out how many extra electrons I have from the net charge, and then use that to go back into here. So the other kind of subset I could do here is say that, okay, my number of electrons equals my number of protons plus the number of excess electrons. I'm going to call that NB plus. So Q equals this. So I'm going to now substitute in negative 4.02 times 10 to the negative 17th coulombs equals NE plus times the charge each one carries, which is 1.602 times 10 to the minus 19th coulombs. And I get an NE plus value of, let's see, I don't really need to worry about the negative there, because I could have just as correctly labeled that as negative. So I'm going to do the 4.02 EE negative 17th divided by divided by 1.602 EE minus 19th. And that tells me that there's, now I need to round that to a, can I have 0.936 of a proton, of an electron? No. So there's 251 extra electrons on my shirt right now. Okay? So now I'm going to go back up and use, that means that the number of protons, or the number of electrons, equals the number of protons plus 251. And now I can use that first fact that they gave me and substitute in for a number of electrons, the number of protons, plus 251, plus the number of protons, for me equals 1485. So I get 2 times the number of protons equals 1485 minus 251. And I get the number of my protons to be so 1485 minus 251 divided by 2. I get 617 protons. that means the number of electrons is going to be 617 plus 251. And I get 868. So let's check that before we go on, just to make sure. Good. All right, and so we're halfway, well, we're at least halfway done. We now need to figure out how much mass is added to our shirt. Each proton brings a certain amount of mass with it. Each electron brings a certain amount of mass. So working over here, our new mass, our mass total, will equal the mass the electrons bring to it plus the mass the protons bring to it. And so the mass the electrons bring to it will be the number of electrons times the mass of an electron. And this should be, let's use a lowercase m here, plus the number of protons plus the mass of a proton. You know the number of protons, you know the number of electrons. You can find on our equation sheet, back to those facts and constants. Remember, it's on the back of your rubric. You have the mass of an electron, 9.11 times 10 to the minus 31st kilograms. And you have the mass of a proton, 1.672 times 10 to the minus 27th kilograms. So that's the mass of the individual particles. You know how many extra electrons you have? 868. How many extra protons? 617. Little multiplication, you got the answer for the mass. All right? All right, we're going to do number 5 here. When a glass rod is pulled across the subcloth, the glass rod requires very, very similar to the last one, in that we're talking about an object being charged. And of course, the objects are charged by moving electrons, never moving protons. So here in your Y, you should have that electrons move from, electrons move from the rod to the silk. Each electron has one quanta of negative charge. Yeah, I think that's about all you really need for the Y there. No forces or anything, so they give us that the glass rod has 0.14 microcoulombs of charge per centimeter. So for every centimeter, I can rub off 0.14 microcoulombs of charge. My goal is to transfer this many electrons. All right, so it comes back to our net charge equation, which is that Q equals NE, and our Q, but now this is the number of so our Q, we need to figure out how many electrons we need. My Q I'm trying to get is 0.14 microcoulombs. So this is 0.14 times 10 to the minus 6 coulombs equals N, and then the charge on each electron really tell me how. Oh, never mind. Sorry. So yeah. So if I have that charge, how many electrons are this charge? So that's 1.602 10 to the minus 19th coulombs per electron. And so to make a charge of 0.14 microcoulombs, oops, sorry, I would do 0.14 e minus 6 divided by 1.602 minus 19th. That's another good number to store in your calculator. And I get that that's charge is going to be made by 8.7390765 times 10 to the 11th electrons. So every centimeter of this rod has this many electrons able to be removed from it. And so if I need to remove 4.1 times 10 to the 13th electrons, times 10 to the 13th electrons, and if in what distance, if every centimeter I have available 8.739076155 times 10 to the 11th electrons, I can I need to rub it for 46.9 centimeters. I could have thrown a lot more units in there. I'm just trying to go quick. Our bell's going to ring in now. Right, so make sure you do finish these up for homework. And I'll post the video.